Hey everyone, my name is Chelsea Shaner, and this is my final project where we are investigating and creating about the electromagnetic field of a horse's heart. I chose this topic for a few reasons. My family owns two horses, Jerry and Two Socks, and they have been very beneficial in equine therapy for PTSD within our family. It is extremely personal to me, and I was very curious about the physics behind how it works. What I discovered is that a horse's heart is about 5 times larger than a human's, and its electromagnetic field can reach up to 10 feet away from its body. It's not just a saying. Horses genuinely have a measurable physical field. Socially, there are over 200 equine therapy programs across the nation used for treating PTSD, anxiety, and autism. So, understanding the physics behind it gives it a real scientific backing to prove its effectiveness. So, how does a heart create a magnetic field? It really comes down to the moving charges and electricity in our bodies. The body uses electrical signals to trigger contractions in the heart. These contractions move millions of ions like calcium, potassium, and sodium, which, when moving together, create something called a biological current loop. Current loops produce magnetic fields. Horses' hearts are special because it's about 10 times heavier than a human's heart. For comparison, while a horse's electromagnetic field can extend 8 to 10 feet, a human's is only 3 to 4 feet. To model this, we treat the heart like a magnetic dipole, so like a bar magnet with a north and south. Looking at the diagram, we see that the top acts like the north and the bottom acts like the south. 3 equations we need to know to complete this project are the dipole moment equation, which will show us if a bigger heart has a bigger field. Secondly, the dipole field equation, which will tell us the strength of the field as the distance changes. Lastly, Faraday's law, which will tell us the changing magnetic field also creates an electric field. Now we calculate the horse's field strength at different distances. First, I need a dipole moment, which for my research, they have a biological current of 50 milliamps and an area of about 600 centimeters squared. Plugging this in, we get to see that at 1 foot away, the field is 222,000 picotesla, and by 5 feet, it drops to 1,700. Even though the drop is steep, the field is still strong enough to interact with nearby humans and their nervous systems. In the investigation portion, I wanted to compare a human's electromagnetic field directly with a horse's. The difference is clear across the board. A horse's heart is 11 to 15 times heavier, has 12 to 16 times more volume, and produces a dipole moment of 30 compared to a human's 8 ampere meters squared. Because the dipole equation is linear, the 3.5 ratio is maintained across every distance, so a horse's field is always exactly 3.5 times stronger. The reach difference is smaller by about 2.5 times because it's scaled with the cube root of the moment and not the moment itself. I want to determine this actually mattered biologically and if horses really made people feel calmer. The best supported mechanism that supports this is heart rate synchronization. It's called biological entrainment. HeartMath Institute found that a human's heart rhythm can synchronize with a horse's rhythm within 3 to 5 minutes of proximity, not even contact. It was confirmed in a study in 2011 that a horse is the driving synchronization. The horse's rhythm changes first and the human follows. Because the heart rate of a horse is so much slower, the human heart rate slows to match and it shifts the nervous system to a calmer state. For my create, I made 2 different models / simulations in Python. This first one maps the full magnetic dipole field of a horse's heart. The field lines we can see are looping from the top of the heart to the bottom, just like a bar magnet with a north and a south. The red arrows are used to demonstrate the strength and direction of the field from each point. My second model shows a direct comparison of a human's field next to a horse's field. The horse is represented by the cyan ring and it extends significantly further than a human's magenta ring. We can also see that the horse's red arrows are bigger and brighter than the human's, showing that the field is 3.5 times larger. This explains how a human can be directly affected by this much larger and stronger field. All of my references, Python code, and class problem are linked in the Google Drive on the slide. Thank you for watching.